Hey guys, welcome back. In today's video, we're going to be talking about mesh analysis, also known as loop analysis, and we're going to go through some problems and talk about some concepts you need to know uh, to solve these problems. Let's get started. Okay, before we dive into some problems, we're just going to go over some stuff that you have to know beforehand. You have to be familiar with KVL. KVL is Kirchhoff's voltage law. Basically, it states that the sum of all voltages around a closed loop has to equal 0. You have to be familiar with this law in order to solve these problems. Something else that you have to know is you have to be familiar with the polarity of voltage. So let's say, for example, you have a battery source like this, and there's current going through the source this way. That's positive and that's negative, like we talked about in the last video. So if this is the case, is there going to be a voltage drop or is there going to be a voltage increase? Well, there's going to be a voltage increase. Whenever the current is traveling from the negative side to the positive side, there's going to be a voltage increase. It's the opposite case if it's going from positive to negative. So, if the current is going to be traveling this way, you're going to have a voltage drop. Something to note is resistors will always cause a voltage drop. Your current's going to be the direction of the current. If it's this way, the resistor's polarity is going to look like that. It's always going to cause a voltage drop. You're always going to have negative voltage for resistors. Okay, now that we know that, let's hop into some problems. Okay, so before we hop into this problem, we're just going to state some steps you need to use to solve all these types of problems. First, you define and draw the direction of your current. Next, you're going to apply KVL, and since V equals IR, you sub in IR instead of simply V. These two steps right here go hand in hand, as you could just do that in one step. You repeat this process for every single loop, and then you solve the corresponding equations that you found in order to find the currents. Now, let's try this. So first step is to set and define all current directions. So we're just going to say that I1 is this way and I2 is also this way. The directions you pick do not matter, as if you choose the wrong direction, you'll simply just get a negative answer as your final answer, and you could just switch that at the very end. So if I decided to do like this instead, it would not matter. Let's all just keep it like this. Now, we're going to go through the first loop first. Loop 1. So you're going up through the battery right here. When you're going from positive to negative, we know from what we said before, that's going to be a voltage drop. So you're going to have -6 here. Now, we're going through the resistor right here. And as I noted before, whenever you go through the resistor, the current is traveling this way, you're going to have a voltage drop. So you're going to say -6 times I1, because that's the voltage. Since V equals IR, the resistance is going to be 6, and your current is I1, and you have to put a negative because of that polarity. Okay. Now we're going to go to this part right here. Now, there is actually two currents that is affecting that resistance. So, the current that's actually traveling through this resistor is going to be I1 minus I2. Since you're doing the loop 1 first, you always assume that that current is dominant. Whenever you're going to do these problems, you just have to note that. So I assume that I1 is bigger. So I'm going to have minus, because the polarity, is gonna be like this if I1 is bigger, minus 6 times I1 minus I2. And all of that is going to be equal to 0 since we know that law in KVL. Now we could expand out the 6 and simplify some stuff here. I2 equals 0. And you're going to have negative 12 I1 plus 6 I2 minus 6 equals 0. This is going to be your first equation. Equation 1. Now we're going to move on to the second loop. Loop number 2. We're going to do the same exact thing. First, let's start off going through down here. So we're going from positive to negative. What does that mean? That means there's a voltage drop. So you're going to have negative 24 volts. Now we come up through here and we have the same kind of scenario we had last time. The voltage, the current that's affecting this resistance is both I1 and I2. But this time we're in the second loop, so we're going to assume that I2 is dominant and the polarity is this way. So we're going to have minus 6 times I2 minus I1. Then you move up through here and you have minus 4 I2 because the polarity is going this way because it's a resistor. And you're always going to have a voltage drop across a resistor, equals 0. And we're going to simplify this to make it a little easier. 24 minus 6I2 plus 6I1 minus 4I2 equals 0. Let's just collect everything. Now you have two equations and you have two unknowns. You could simply use substitution or elimination to solve these equations, but my calculator you could type it directly in, and if you have a scientific calculator you most likely can do that. So I'm going to do that, but you guys can confirm my answer. So for I1 we have negative 2.43 milliamps because we're working in kiloohms. And for I2 we have negative 3.86 milliamps because we are working in kiloohms. So we got negative answers. What does that mean? Well, that means that the direction we chose for the current over here, this clockwise direction, was actually incorrect for both of the currents. And the real direction is this way. Whoops. The real direction would be this way, counterclockwise. So you could just state in your solution that the direction that you chose was wrong and that it's just the opposite direction. Okay, so now we're going to hop into another example. As you can see, this example is slightly different as there's a current source right there. So we're going to see how to deal with that in just a moment. So this question is asking us how to solve I2. First thing we're going to do here is define our directions. It was already given to us here that I2 is that way. So we're just going to write down I2. And then we're going to define this as I1, that loop. Now, if you look at loop number 1, Do you need to do KVL across that loop, or could we just look at it and see what I1 is? Well, we know that since there is a current source on the edge of this loop, and it's not being shared between any other loop, that I1 is indeed simply 2 milliamps. So we actually don't have to go around and do KVL like we did before for that loop, and this actually makes our life much easier. Now we know I1 is 2 milliamps, we could find I2. So let's look at loop number 2 here. And now let's start with this 3K and we'll move down from there. So we have 3K and we know the polarity is like this because that's the direction of the current is going down, and we're always going to be losing voltage. We're having a voltage drop whenever we go across a resistor. So we're going to have a negative because we know we're going across the resistor, so we lose voltage. And we're going to have negative 3 kiloohms times I2, which is that voltage. Now we're going to go up and through the 6K. So the 6K, there's two currents that's affecting it, I2 and I1. But we assume I2 is dominant because we're talking about loop 2. So we know that the polarity is going to be like that. And you're going to have minus, because we're also going through a resistor, so it's negative always, like we said before, minus 6 times I2 minus I1, which is 2. And because we're assuming that I2 is dominant because we're talking about loop 2. Now we go up through this 3-volt battery. Since we're going from negative to positive, that means there's a voltage increase. So we're going to add 3 volts to that. And then we finished our loop. Okay. So we set that equal to 0. And we're just going to simplify some stuff. 3i2 minus 6i2 plus 12 plus 3 equals 0. And now we could simply just isolate for I2 and solve for it. So I2 equals negative 15. Negative 9i2 equals negative 15. And if we divide negative 9 by both sides, we're going to have I2 equals 15 over 9 milliamps. And those are your two currents for this circuit. That's going to be everything for today's video. If you learned something new, please like, comment, and subscribe. Next video, we're going to be talking about more advanced loop analysis. We're going to be going over super loops, so stay tuned for that. Thanks.